Hi, this is Nishchita. I'm from NYU Poly, and today I'm making this video as part of my homework for probability in stochastic processes. This is homework for question 1. In question 1, we are given y is equal to g of x, which is a function which is given as 1 for x is less than 0, 0 for the interval 0 to 1, minus x plus 1 for the interval 1 to 2, and minus 1 for x greater than 2. So, based on the given question, we can draw g of x as follows. It is 1 for x less than 0. It drops to 0 for the interval 0 to 1, and then again it further drops based on the equation minus x plus 1 from 1 to 2, and then it is constantly minus 1 for x greater than 2. The given question asks us to find capital F y of y and small f y of y in terms of fx of x and capital Fx of x. So the small fx of x is given. It is as shown in the diagram here. So based on this, we can draw capital Fx of x as an increasing function between 0 and 1. And now to find fy of y. So in order to find fy of y, we split fy of y in between various intervals and then consider the given equation at that particular interval. So for a y less than minus 1, fy of y is nothing but p of y is less than minus 1, which can also be using the given equation. We can see that when y is less than minus 1, x is greater than minus 2. So replacing that, we get p of y is less than minus 1 is nothing but p of x is greater than minus 2, which comes to 1 minus fx of 2. Similarly, for the interval minus 1 to 0, p of y is less than y is nothing but minus x plus 1 less than y. So if it is transferred to the other side, it becomes x is greater than 1 minus y. So it comes to 1 minus fx of 1 minus y. So if y is greater than 1, fy of y is p of capital Y less than y, which is x less than 1. So it comes to fy of 1 is equal to 1, which is fx of 1. We also need to find the equation, the values of fy of y at particular switching points. So for y is equal to 1, fy of y will become p of y less than 1, which is nothing but p of x greater than 0, so 1 minus fx of 0. Similarly, at 0 also, p of y less than 0 is p of x greater than 0, so 1 minus fx of 0. Based on all the various intervals that we have calculated, we can just jot down fy of y as 1 minus capital Fx of 2 at y is less than minus 1, which comes to 0 because fx of 2 is 1. So 1 minus fx of minus of 1 y minus 1 for the interval minus 1 to 0, 1 minus fx of 0 for the interval 0 to 1, and 1 for y greater than 1. So based on these plots, and taking if this is a positive plot, we can map the inverse plot like this. So plotting those using these plots, we can finally plot capital Fy of y as shown below. The one which is darkened is the capital Fy of y. So using capital Fy of y, we can find out small fy of y, which is again taken as 1 minus, which is again taken in the basic the same intervals. So for y is less than y is equal at y is equal to minus 1, it becomes 1 minus fx of 2 into delta of y plus 1. At y is equal to 0, it becomes fx of 1 minus fx of 0 multiplied by delta of y. At y is equal to 1, it becomes fx of 0 into delta of y minus 1. And similarly, at interval x is equal to y minus then it becomes f of x divided by g of x, modulus of g of x, where x is equal to minus y plus 1, so it becomes f of x by modulus of minus 1. That is nothing but f of x of 0 into delta of y minus 1 for the interval minus 1 to 0. So if you plot that, we can see that fy of y at minus 1, it is again an impulse function. At 0 also it is an impulse function. At 1 also it is an impulse function. But at minus 1, it is multiplied by 1 minus fx of 2. At 0, it is multiplied by fx of 1 minus fx of 0. At 2, it is multiplied by fx of 0. And this is the interval between minus 1 to 0 can be represented with this increasing function, which is fx of 0 into delta y minus 1.